Alrighty. Welcome to the frequency community call for 20th March 2020. It is not 2024. Apparently, I'm off by a year. I apologize. Um, we have a packed agenda for today. So the first thing on the list is what's coming up in releases. So working towards a couple features in the next release. The first one here is the time release scheduling improvement. So this is a small improvement to the time release palette to allow future time release transactions to be scheduled into the future. Um, so that's useful for a couple different programs that we have in mind and have talked about with the Frequency Network Foundation. So excited to see that happening. We'll see that in the upcoming release. Also, I'm going to pass it over here for a second to Shannon to talk about what's coming up in the new Polkadot SDK upgrades that are being done, upgrading to version 24.12. Shannon, are you available to take that away?
Yes. Yeah. We are in the middle of, as Will pointed out, upgrading to Polkadot SDK version 24.12. It was a little bit of a slog at first, but once the first 24.07 was working, 24.9 was pretty smooth sailing. And now I am working on the upgrade to 24.12. Um, so one of the major changes to this SDK was in changing signed extension to transaction extensions. That's a pretty big refactor. For those of you who are not Substrate, Parachain, Rust programmers, a signed extension is a module that you can customize or write yourself to look at all the transactions coming over the line and decide if there's something you need to do with it. And In our case, a signed extension is what allows passkeys to work. It allows capacity to work, and it lets us do things like make certain transactions for free. And so it's kind of like a little filter with some processing. So that's very important for us to get upgraded properly. So there's what they did was they built a wrapper to help you do the transition if you weren't able to do the upgrade all the way to transaction extension. So that is what I'm working on right now. Back to you.
Cool. It's definitely an exciting upgrade and improvements. I think one other big improvement that's coming along with it, it might be just after it, is change to a fork-aware transaction pool, which helps with some of the transaction pool processing for all the nodes as well. And there's a ton more coming in it, so we'll have to link to all of the different release notes in that next release. As always, we also do like to look at our mainnet activity. So we're going to switch over real quick, oops, to frequency metrics. So number is going up. The graph activations. So this is the number of users on chain with graph at almost 850,000 now. And that number keeps going up right as we're watching it. So that's also very exciting there. So let's go over to a few of the other things on the agenda. A quick note, we had a great time at ETH Denver. A couple of us from the community went. One of the things I did was give a talk on stage Captain Ethereum for the case for smarter, more use-specific sidecars. So that is available on YouTube. We'll make sure that gets posted again into Discord. I think it has already, but we'll make sure that one gets in there as well. There was also a frequency house. Frequency Network Foundation took over a coffee shop and had some great talks and discussions happening in the coffee shop. So if you missed out on that at ETH Denver 2025, we'll have to make sure, see what we can't, see if that sort of thing is not happening again at some other events and let people know. So other than that, we're going to switch over now. Let's see if I, well, we're going to skip past this next one because I don't see the person who's going to talk about it. And we'll give a quick shout out to the sign in with frequency SDK. So this is from Project Liberty Labs, building on the sign in with frequency standards. And so there's now still need to work on the version 1 update should be coming out very soon, but there's now a nice SDK for anyone who is using it on iOS as well as on Android. And if you're not familiar with the sign with frequency standard, there's a whole bunch of documentation and available, but effectively it makes it super easy to just get started with using frequency for single sign-on, using any sign with frequency compatible service such as frequency access. So excited to see these coming out. Big shout out to Claire, who did a ton of work making these both easy to use and getting kicked off nicely. Okay, with that, we're going to come back to this one. It looks like the person might be able to join a little later, so we'll talk about that one in a little bit. Now we're going to move on to an Ethereum update. So a couple things have been happening here, but I think one of the biggest pieces of including Ethereum, making sure that we have it available to as many people as possible. One of those big pieces is updating to Ethereum standard keys. So I'm going to pass it over to Aramik if you're able still to talk a little bit about the path to key migration to Ethereum style keys and signatures on Ethereum. Aramik, take it away.
Yeah, sounds good. Can you hear me?
We've got you.
Okay, cool. Yeah, thank you, Will. Basically, so if I give a short context, what we're trying to do, basically, we are trying to allow Ethereum compatible keys and wallets work with frequency. And for that, we might need to migrate some of the keys that are substrate and Polkadot specific keys such as SR25519, ED255. I mean, yeah, SR is pretty specific. ED is used other places, but the standard that's mostly used in Ethereum is SSCP256K1. And that is the type of the keys that we mostly need to migrate to. So to add support for those, we need to migrate existing keys to that SCP-256K1. And for the migration, I figure out we can maybe do it in 3 phases. The phase 1 would be just migrating the control keys. It's easier to do because they do not usually hold token. The other one, the phase 2, would be mostly migrating any token keys that are not involved with the multisig. And the phase 3 would be multisig and whatever is left. The multisig is a difficult one because it depends on underlying accounts, and the way the multisig is being done in frequency, not just frequency in Polkadot ecosystem, is a little different from whatever is the standard in Ethereum. So we have those three phases. One of the reasons for migration would be the account ID and account size. Account ID size is basically different. On Ethereum, we have 20 bytes for each account ID, an address, and but on Polkadot ecosystem and frequency is 32 bytes, and we need to find a way to map those 32 bytes to 20 bytes in a standard way. It has been done in different ways, but the way we're gonna do it is basically the way that Parity is looking into to add more support for EVM and Ethereum. So we're gonna go the way that they're uh, basically gonna support. So that's gonna be one of the ways to do that mapping. The other part would be allowing signatures that are compatible with MetaMask and Ethereum and all those standards. Yeah, so we can use all those existing wallets on Ethereum ecosystem. I think that's it, unless you have something else in mind, Will.
That's great. We'll have it open here for open questions as well. So if anybody has a question, feel free to throw a note in chat or throw up a hand, and we'll get you up to talk about it. But it's exciting. That's one of the largest pieces, I think, of the including the Ethereum ecosystem in the frequency community. Other pieces we're still working on trying to figure out. Pieces like how can we make sure RPCs are working for Ethereum users, and there's a couple different paths we're looking at, but excited to see the ecosystem being able to expand and interact with more wallets, more users, and making things easier. So with that, we'll go to some of our open questions. I don't see any in chat right now, so we will keep, if anybody does have one, feel free to throw it in. We'll make sure to get to it by the end of the call. But we're going to switch over now to a discussion about the, oh, there is one posted and I missed it in the Q&A section. All righty. So this question, Aramik, is actually for you. Control keys, quote, control keys usually don't hold tokens. Do we have a scenario now when a control key does hold a token? Is this something being considered for the future? Aramik?
Yeah, so we have some legacy hold account control keys that are associated with providers, and some of those providers basically have some tokens. So that's why, like, I would say 99% of the control keys don't have, but some of the providers might have control keys that they have token with it. So, but these are more legacy. Oh, we can't hear you, Will.
Thank you for that, and thank you for that question and the note in chat. I now have it open to make sure those messages get to me. All right. With that, we'll move on to our discussion item for the day. I think Joe is going to talk a lot about this. He's been doing some of the research and work on it. Schemas 2.0. I'm going to pull up the GitHub issue and I'll take notes. But Joe, do you want to take it away and kind of describe some of the potential changes being discussed in the whys?
Sure, thanks, Will. So a little background on this. First, we currently have schemas on frequency as it is deployed now. Schemas are basically just data descriptors, essentially, that you can attach permissions to. So we store schemas on chain. in the schemas palette. And typically the schema definition has a few pieces of metadata. It like where the storage location for data associated with that schema would reside. Um, so storage locations could be on-chain. Off-chain location would be IPFS, and we also have storage locations for our specific stateful storage palette, which would be itemized storage and paginated storage. Those are the four places that schemas can indicate that their data resides. Schema names were sort of introduced later on as a convenient way to look up because schemas are idempotent, right? We can't change a schema once it's deployed on chain. So when we want to make an update to a schema, we have to deploy a completely new schema. That new schema has a new numeric ID, and we thought it would be nice to be able to discover, when there's a new schema available for the same what we're now calling a protocol. So the issue that arises with this, some of the concerns we have are with delegations. Currently, when we delegate permission from a user who delegates permission for a particular schema to a provider to act on their behalf, that delegation is recorded with a numeric ID, which is a specific deployed schema version. So in the case of, say, DSNP dot update, as we've got in the issue example here, that might be schema ID 7, let's say. A new version gets deployed to the chain. It's schema 25. Now you have to discover that. You have to, a provider might ask you to redelegate permission. We don't know what changed, but because there's no code associated with the schema itself, it's just a data format. The changes are limited to what they can be. It's a change in the data format. Now, it could be a significant change. It could be that, hey, we added a field for your password and we're going to store that now. So you don't know what it is, and that's why, hence the bullet point here about protecting users from bad schema upgrades. So the upshot of this is we would like to sort of figure out a good balance between how can we reduce friction for users in constantly asking them for new delegations when there are minor updates to schemas, but still protect them from bad actors. Right? So this is where we start throwing ideas against the wall and seeing what sticks. We've thought about ways that we can enhance delegations to be able to give the users more control. One idea that I floated is the idea that a delegation, instead of being a delegation to one specific schema ID, might be a delegation to some sort of pattern, maybe at the protocol level. So you could, for instance, maybe delegate to DSNP dot update at star, which would indicate that you want to delegate to all versions of the DSNP update schema, past, future, present, etc. You could think of ways that it might be possible to limit that. As a user, I might want to say, well, I've reviewed all the existing schema versions for that DSNP dot update, and I'm okay with those. So I want to delegate to all of those. But I don't want to automatically delegate to future versions. I want to reserve that permission. So, maybe we have the ability to put ranges of versions. Say I want to delegate from 0 through current, something like that. My feeling on the matter is, give the user control. Certainly because we have registered namespaces, right? The DSNP schema namespace and any particular schema protocol within that namespace is going to be owned by the DSMP organization. So it, I think it kind of becomes a matter of trust at that point. Do you trust the owner of this protocol enough to want to grant them sort of carte blanche on this schema for any future updates they might publish? And that trust might be based on a combination of how much you trust the organization and also how much you think what's the potential for harm with that, right? So, for instance, the permission to broadcast content. So, what's the permission for harm with that schema? What information, what fields might a provider or a schema owner add potentially to that schema that you feel would not be something you would, you know, want to have them be able to record on chain. Um, any questions? Any comments? I see some comments in the chat here.
Yeah, in chat, there's a note about semantic versioning,
Right.
updating in that level. I think even the semantic versioning, though, like you were saying, Joe, comes back to that question of, do you trust the protocol, right? If you uh, as has been known to happen in a few JavaScript packages, where a patch version makes major changes, and so it's a question of who is able to make and approve those changes. And if it's the kind of the protocol organization managing the protocol, it's still a level of the level of trust is if they can do a patch update. It still has some level of normalization, I think, but it's definitely a complex bit of the trust cycles there.
Yep. The thing I like the idea of semantic versioning. Um, it would be something. So, there are also trade-offs here, right? Because when we think about how to store this stuff on chain, we have to think about the storage impact and the processing impact because checking delegations is a very frequent operation on chain. A lot of extrinsics have to check schema permissions, and that needs to be an efficient operation. So because then it becomes a question of, monotonically increasing version IDs might be much more efficient to check against than a semver algorithm. Uh, it's a thought to consider. I like the idea of semantic versioning. We would just have to see if it can be done in an efficient way. Ironic?
Yeah, I think there's a distinction between checking delegation for read and write. The read, it doesn't matter. You could make it as complex as you want, but the write, since it is an on-chain write, yeah, that's going to be costly.
Exactly. And the thing is, it's right. Whatever the algorithm is has to work for both. So if we're going to use semantic versioning, it has to be. I mean, you're right. We don't care so much if it's expensive on the read side, but it has to be efficient for write because that's where it's checked on chain.
Yeah. Anyone else have any thoughts, input on this and specific ideas? Uh, if not, let's specifically focus in on kind of uh, let's focus in on the problem of delegations in particular, because I think in some ways are you allowed to upgrade as a kind of a protocol owner is very much a, hey, do you trust the protocol owner? There's certain ways we can handle that. Let's focus in for a second here on the question of the delegation kind of batching more than one delegation. And I think this has an interesting point in some level of delegations. There's more than one schema kind of required I can imagine a place where there's two different pieces of data and you have to be able to effectively change both for some particular reason. Aramik?
Yeah, I'm curious how this might be close to updating a term of service. Like if you see any term of service changes, then like they have to ask the in Web 2, the user that to approve that. Is this kind of similar to that, or how is it different?
I think that's a good point, is that one way to think about this is even if at the minor updates it could be, I would say at least, and Joe or others pop in here, there's a level of which some of these are definitely a terms of service update, right? Where I want to do a different thing than what I'm doing now. And I think a good kind of level of that is the idea of, hey, there's, you know, let's say a DSMP update and uh, frequency token addresses, right? Two different schemas, two different protocol namespaces. And if somebody's asking for permissions on both of those things, or they only had one and they want to add another one, it's definitely a change in permission capabilities in that they're asking to say, hey, I want to edit or have access to a different set of data. So from that perspective, it definitely is. And I think there's a level of, hey, DSMP update versus DSMP broadcast versus something else. Those are different permissions, different pieces of the terms of service. I think that it becomes a lot more complex when we talk about versions. And I think this is where it gets interesting and goes back in some ways to that level of like trust. A lot of the version updates are much closer to, hey, we tweaked the data structure, right? Or we changed this data from a format of a string to a format of an integer. Things that aren't actually changing the data, they're just changing the data structure. And that would imply, hey, we need to bump the version so people know how to read the new schema, but it's not actually a material change for a user. So when a user goes and says, there's not that same terms of service requirement. However, again, going back to that trust in the protocol, there's no way to know, right? As the frequency as the chain itself to be able to determine that it's a non-material upgrade, right? Because you could say, oh, and this can happen even without updating the schema. You could say, oh, we're going to interpret this data as being uh, somebody's personal information when before it wasn't. Or we're going to just fill in, we're going to, instead of using this identifier, we're going to use some identifier that we shouldn't be using in place of that, right? There's always going to be that level of trust in both the protocol and the people you've delegated to, the providers you've delegated to, that they're going to use that data in good ways. But it's not the same level of interacting with kind of a full change. So this is, I think, where it's a good question. It gets back to that trust level of, should we be on the side of effectively saying, hey, we can't know, therefore we want to make sure it is as trusted as possible? Or do we want to be on the side of, hey, you're trusting the protocol, and at that point, if you're trusting the protocol, like how far do we want to take that protocol level trust? And then also, instead of the delegation, the provider level trust, right? Right now, the protocol level trust is the trust that the chain governance that approves new schemas is operating with the best intentions of the users. Whereas I think with a change where the protocol has any level of more power, the trust shifts a little bit to the level of, does the protocol group have the best interest of the users and aren't going to do a version update that compromises kind of the point. And instead, if they have something that does react to more of a terms of service style change, they'd actually be, changing the schema, not just the version, but the whole schema to build a new schema with that kind of new intent to the user level. That was a long way to say, it comes back to trust, and who do we want to trust on which pieces? Wes, go ahead.
I missed the first part of this. Apologies for that. Today, it is the case that there's not an author or an owner of a schema. Is that correct?
That is correct. At this point in time, there is not. We have the implied ownership at the kind of the protocol namespace level, but it is merely an implied ownership. And we could, as part of this, move that to an actual, on-chain governance type setup. But even if it's just implied, there's still some level of, even if the chain governance still approves the update to the schema version, there's still kind of this level of it's going to approve ones that are kind of from the organization requesting the inside of that protocol namespace.
Yeah, we could have a whole separate conversation on namespace ownership and how to manage that. I think that's at the end of the day, I think for purposes of this conversation, it's sufficient to know that there is some trusted mechanism by which that works, whether it's just overarching chain level governance or whether it's some other sort of ownership registry that gets implemented.
I think the biggest question to me is there a path where, like almost everything else protocol driven on the web, the user doesn't need to care about the exact changes of the protocol. And we don't have that today, right? Every time you make a version change in the schema, no matter how minor, we would need to get a new delegation from the user. And that's a design choice, right? I get that it's a design choice we are debating. I'd probably start from the premise that it's a design choice that doesn't exist in anything else I've seen, which is not to say it wasn't put there for a reason. It's just to say we have created a point of friction that we need to debate the value of.
I mean, I think if we look at maybe a concrete example, like for instance, let's say I've delegated the DSMP broadcast protocol, which gives a provider the permission to post content on my behalf. And I'm happy with that. I'm happy with delegating all versions of that protocol. And for whatever reason, let's say that it's deemed appropriate to add a field to the DSNP broadcast schema indicating geographic location, lat long coordinates or something along those lines, Now that would probably be something that a lot of people would take exception to. However, by the same token, it's a nefarious actor who wanted to track your geolocation could probably stuff that data into some other field that wasn't intended for that purpose, but could be represented as string data or whatever, and achieve the same end. So the presence of a field does not indicate that it must be populated, I think. It's really so again, it comes down to the trust really at both the protocol owners level and also the providers to whom you've delegated those permissions. Like I might want, even if DSNP adds a geolocation field to the broadcast message, I might want to choose a provider who espouses the intent not to populate it.
I'm going to try making a statement here for as we start to kind of move this towards some actionable outcomes. I'm going to make a statement, and I want people to kind of pitch in either in chat or in voice if they agree or disagree with it. A kind of a version of this at a higher level is that users should not need to approve version new versions of a schema. So just pure a pure statement there. Let's not worry about how it happens or anything like that. But is that a statement that people agree with, disagree? Throw it in chat. Throw it up on. Throw a hand up if you want to talk about it.
I mostly agree with that statement. I'm wondering if, I mean, I hate to put too much governance around things, like, you know, and then, it still becomes a matter of trust. Like, let's say as it currently is, you need governance approval to publish a schema, or at least to register it with a name. So, you know, at that point, you're trusting that no schema updates are going to be allowed that would represent a, significant material change. Like, this is a DSNP dot broadcast schema, but I'm completely changing it to represent some other data. Um, so yeah, there is that level of trust, but I mean, I think you need to have that level of trust. Otherwise, the whole system kind of doesn't work.
Yeah. Let me put in here where new versions of a schema are not not changing
The intent of the schema.
yeah, changing the intent schema. I think that's a key piece. And again, how exactly we prove it, what the trusted level is on that, we still need to figure out. Aramik, go ahead.
Is there a thought about maybe treating DSMP differently than other general schemas because it's the native usability case, and the company is also supporting that. So the thing is, I'm like, what if we have more trust on DSMP and what it can do, but for other schemas, we would have more options like that?
I don't think there's anything special that would be required for it. I'm trying to think through off the top of my head if there's any reason. I know that the DSMP needs for schemas has a higher number of schemas, of individual schemas, than most other systems that we've looked at, that I've looked at least. Uh, many other protocols are much more narrow and only have kind of one piece of data effectively, or maybe two different types of data that flow across it, because most protocols are fairly narrow if they aren't dealing with something complex like social. So I think you're right that frequency is perhaps DSMP is perhaps a special case where it is much more complex than these other ones. But I don't, off the top of my head, I don't see any reason to treat it too much differently. But it does make it, it's an interesting case, I think, to be made that something like DSMP kind of may need a protocol owner and a trust and a protocol that manages it separately from chain governance, whereas a lot of other protocols probably don't have that same level of requirement. And just doing the kind of the current frequency chain governance as opposed to a separate governance just for the protocol is probably enough, right? I'm thinking of like there's some time protocols that we've looked at implementing for anchoring hashes and things to time, and there's just one thing, right? It would be a very straightforward one in that case, or things like publishing real estate listings. Again, pretty much just one specific schema, not a suite of schemas. All right. Okay. So if we assume this, I think the outcome of this outcome is schemas should, and again, I'm looking to the chat and people throwing up their hands, but schema versions should be restricted to updates that do not change the intent. And then the secondary outcome of this would be, if I could type and talk at the same time, is that users should not need to approve a schema version, a specific schema version. Now, whether or not this is still possible to do, question, is it possible to do it even if it is not common? I'm unsure about that one, but how do people feel about kind of this outcome? This would be a change that we'd figure out how to make. Obviously, this requires a lot of other changes around the schema structuring to do that, such as right now, schemas and schema versions work a little bit differently. But thoughts about this specific change coming to frequency? Any comments? Go, Joe.
I think so. This would seem to imply that the existing versioning scheme, i.e., monotonically increasing integers, is sufficient because basically all schema updates are patch or minor level updates, and anything that would be considered a breaking change would have to be a new schema. So you would have, DSNP.update. I'm fine with delegating all past, present, and future versions of that because I know that any updates to that registered name will be non-material. If there needs to be a material change to DSNP update, it would need to be deployed and registered under a new protocol name, i.e., DSNP update v2 as the actual name of the protocol.
I think that makes sense. I think that also means that as far as this like question here goes, I would say the answer is no. Just that is not something we want to have to deal with at the chain level, specifically kind of going back to those costs of checking on chain and the complexity involved. I I think this also comes down to is currently, I guess another note, currently it will be the responsibility of frequency governance to ensure that the update does not change the intent. So the trust model is still is a little bit different, but effectively still the same. And I think you could make a good case that this actually increases the security for users instead of decreasing the security for users, given that while it is easy to just say, yeah, I give those permissions, the less you see I give those I offer those permissions screens, the more you're likely to look at what permissions are being requested and actually potentially act upon those changes. If you have to, every single time you log into an app, you have to do updates, you're going to get blind to those changes. All right. Well, that gets us, I think, at least a piece of this puzzle. Start moving forward. We'll be discussing more of it in future frequency community calls. I don't think we're going to get too far in implementation for the next month in some of those pieces, but hopefully we'll have some more to report out in kind of designs and structures for next month's community call. Before we go to next month's, I'm going to pass it over to Wes, if you're still available, to talk a little bit about the community update regarding the AT protocol.
Yeah, so we've done some work at Project Liberty on using frequency and some of the approaches that frequency takes with message batching and so forth, to facilitate using that in conjunction with the AT protocol, which is what underlies Blue Sky application, and it is a rapidly evolving protocol, to call back to our previous discussion here, but one that carries social data as well as other things. And this is being, and Will's got the press release up here. There's also a blog post on the frequency blog on Medium that goes into a little more technical detail. I'm working on more examples of that as well. But it's calling it a event archive and backup system. And I want to differentiate those two things slightly. A backup is the ability to take all of somebody's data from AT protocol, which is sort of natively stored in what AT protocol calls their PDS, their personal data server, and we will be facilitating a backup for users' data when they want that, so that if they lost access to their PDS, for example, that could mean simply it goes down. That could mean they got banned, anything like that. They could recover that data and move it to a new PDS in the AT proto architecture. The archive function is based on the same data, but when we look at the way that frequency allows us to create a timeline of content in and messages through the batch model, we're actually creating something that doesn't exist today natively in AT protocol. You could go to somebody's personal data server and get all of that user's data. That is a relatively straightforward thing to do. It might be a lot of data, but you can get it that way. But what you can't do is say, I want to rewind to last Thursday and see what activity was going on Blue Sky at that point in time. And in effect, rewind and play forward the conversations that happened as they happened uh, on the protocol, and that is something that this architecture affords us, and I think that's a very interesting point of it. Not only can it be used as an alternative fire hose, so we could build applications that don't necessarily have to talk to blue sky hosted infrastructure, um, running they run what's called the relay or the fire hose, that kind of aggregates together all the messages across various PDSs, many of which are also hosted by Blue Sky, but don't have to be. But this is a start to saying, well, you could actually recreate the application layer, the view of the conversations going on in Blue Sky without requiring Blue Sky infrastructure to be involved in that process. And not only that, you can also go back in time and look at what those conversations were. Maybe that's as simple as I want to make sure I don't miss any replies that might have come in and over more than 72 hours ago, which is what I think you can get on the fire hose. But basically, we're taking what the strengths are for frequency and applying them to this other protocol, and I think that's a great testament to what frequency is designed for, which is the idea that there is a lot of data that can be expressed across it, and it takes the shape of these protocols, um, and individually each item of data may not be hugely valuable, but in aggregate, we're creating something that is a useful corpus of information and a useful way of retrieving that information as well. So that's kind of my spiel.
Yeah.
Happy to take questions.
That's great. I'll also note that this was done with no changes to frequency itself. So this is kind of, as we were talking a lot there about the schemas and the structure, uh, as Wes had said, really shows the power of that the data structure and capabilities to flex to new data structures and new types of data.
And where that's at currently is if you go explore the chain on testnet, you'll see those batches being published pretty much every 6 seconds on testnet. We're looking at hardening that architecture and moving it to mainnet as the next step.
There we go. There's some of them coming across now. Right there. So there we go. All right. With that, we will call this community call to an end. Thank you, everyone, for the great discussions and helping move the conversation forward on all these great points. The next frequency community call, Thursday, 17th of April, 2025. It'll be at 1 p.m. New York time, 1800 UTC time, and we'll make sure that we put the announcements in all the right places. Thank you very much, and have a great Thursday.